It's now my great pleasure to welcome to the stage Kate Greeneklee. Kate is an honours graduate in microbiology and immunology, and she has kindly agreed, and we're delighted to have her here tonight to present some of the science in favour of consuming unpasteurised milk. So please welcome Kate to the stage.
Thank you, Hamilton. I'm here tonight because primarily my family and I drink the raw milk from the Moo View Farm, and we want to support Mark and Helen Tyler in the light of the recent events. So Mark asked me to talk to you tonight because of my background in medical research. So I have an honours degree in microbiology and immunology, and I've worked in that field for several years before taking a break to have our children. I'd also like to say that I'm not here to put down pasteurisation as being evil. In fact, pasteurisation has been a valuable public health tool in the past and may well continue to be into the future in countries where tuberculosis is endemic, for example, and I'll talk more about that in a few minutes. However, there is a price to pay for pasteurisation in that heating the milk changes it. It changes lots of things about the different components of the milk, and there are negative health consequences for that for some individuals. I'd also like to point out that I'm not intending to verbally attack Biosecurity SA or the Dairy Authority of South Australia, or in fact anyone else who has an opinion that's different to my own. I know that this is a very contentious issue and a very emotive one too for some people, but I feel that that type of verbal stoushing is not very helpful, and it rarely leads to an outcome that's acceptable to all parties. But what I do hope to be able to do tonight is to help everyone understand what inherent risks there are in drinking any type of milk from another animal, what we can do to mitigate those risks, and to persuade you that consuming raw milk from the Moo View cows is no more risky than consuming pasteurised milk. So it would help if I turned it on. Beep, beep. Here we go. Okay, we need to define what raw milk is, and we need to do that because one of the studies I read where participants were questioned about their attitudes towards raw milk and what motivated them to drink it, some of them thought that raw milk was milk you took out of the fridge, poured into a glass and had a drink from. So it was raw because it was not used in cooking. But as most of you will understand, that's not what we're talking about here today. So raw milk that we're talking about is fresh from the cow, not processed or separated in any way. The only thing that's been done to it is it's been filtered to remove any particulate material that might be in it, and it's been cooled down to 4 degrees or less. And you'll see the 3 C's up there on the slide. Keep milk clean, keep it covered, and keep it cool. And I'll talk more about that a bit later. The next thing is that bacteria get a bit of a bad rap. They're not all bad. In fact, they're necessary for life. Most adult humans have about 2 kilos of bacteria in their body, most of it in the gut. They're in our nose, in our mouth, on our skin, they're everywhere. And they help us in many ways. They make vitamin K for us in the gut. They take up space on our skin and in our mouth and on our gut that prevents pathogens, should you come across them, from colonising that space, from living on that space. So they're very much a part of who we are and, how we live here on the earth. It's a symbiotic relationship, so we live because they're here and they live because we're here. I should point out the definition of a pathogen. In this case, the bugs that we're talking about tonight are all bacteria in relation to milk. And a pathogen is a bacteria that causes disease in a person. Another thing is that pasteurisation, as I'll explain in a few minutes, doesn't kill all bacteria. And that's a good thing for us. It doesn't kill all the good bugs, so to speak. And in fact, there is a whole industry out there that plays on people's fear of bacteria by trying to sell you all manner of disinfectants and cleaners and get all of those bacteria off your rubbish bin and off your couch so your children don't get sick. Bacteria are everywhere, and we do need a whole lot of them. I won't spend too much time on this slide, so don't be too intimidated by all the little shapes up there. But this is just to make a couple of points that bacteria generally come in 2 different shapes. There's round ones and elongated ones. So the round ones are called cocci, and the rod-shaped ones are called either rods or bacilli. There are other shapes too, but that's not relevant to our discussion tonight. They're very small. although some of them do like to hang around together. As I've already said, there's a symbiotic relationship between animals and bacteria. A mill of fresh water has about 1 million bacteria in it. A gram of soil has 40 million bacteria in it. And the healthy adult has about 2 kilos if you were able to scrape them off and measure these things. So the point I really want you to take home is that we're not just defenceless sitting ducks waiting for bacteria to invade us and, take over our body and kill us. Because the vast majority of bacteria that are on our bodies, in our guts, are kept at bay by our intact skin, our intact gut, and also our immune system, which patrols our body relentlessly, waiting to jump on any invader that might come inside our skin. Okay, time for some audience participation, if you'd be so kind. We're humans, and cow's milk comes from cows, intended for baby cows. So why do we drink cow's milk? Call out an answer, anybody. There's no wrong answer. Sorry, again from the... Yes. From the back there? Protein, yes. Anyone else like to throw an answer out? Calcium. At the back there? True. A very easy answer is because we can. We drink cow's milk because we can. It's convenient, it's accessible, and it has a whole heap of nutrients in it. Fats, proteins, carbohydrates, vitamins, minerals. Newborn babies, in fact, can get all their nutrients for up to the first 6 months of their life just from breast milk. Everything they need. I think it's worth reflecting on the history of pasteurisation to understand why it was introduced for milk. And most of you might know that Louis Pasteur is the man who is credited with developing pasteurisation as we know it today. People before Pasteur had heated food and beer and wine for long periods of time at high temperatures to try and preserve the taste of it, because it was found that bacteria would spoil it and destroy the taste, not to make people sick. I forgot to say that on the previous slide. So spoilage bacteria are bacteria that use lactose to make lactic acid. They use it as their food source. And that lactic acid leads to that sort of vinegary sour taste that you can smell and definitely taste as well in some beverages and in milk after a few days. And it amuses me, by the way, that all of this effort was put into beer and wine, and yes, it's all very well to, preserve food for troops on the battlefield and so on, but make sure the grog doesn't go off, whatever you do. So, beer and wine. While on holiday in 1864, Louis Pasteur was a bit stirred by the acidity of some of the local wines at his favourite holiday spot in France. And he discovered by experimenting that it was enough to heat the wine to 50 or 60 degrees, and that was enough to kill the bacteria, and then the wine could be aged normally without sacrificing any taste. And by the way, alcohol boils at 78 degrees, so if you're boiling something for a long time at a high temperature, 100, all the alcohol boils off, so that defeats the purpose of making it in the first place. So 50 or 60 degrees was enough to kill some of the bugs, and then they could be aged and the taste was not sacrificed. And so in honour of Pasteur's wonderful experiment, the process became known as pasteurisation. And in fact, it was many years until this was applied to milk. So why was milk pasteurised? One of the first people who suggested it was a German doctor by the name of Franz von Soschlet. And he suggested that cow's milk be pasteurised and given to infants whose mothers had died in childbirth or who were struggling to breastfeed for whatever other reason, and their infants were struggling to thrive. So like blood, when bugs get under our skin or in through a cut or whatever, milk does have great nutrients for bacteria, and this was his way of solving that problem and allowing all those infants to thrive and grow. Another big factor, in fact I'd say it's one of the more critical factors, is the time between milking the cow and consuming the milk. So 100 years ago, people who lived in the rural areas would have had easy access to farms. It wouldn't have been that long a time, so a day, 2 days maybe. But with increasing urban density, you couldn't have a cow in your backyard, and so the cows were sort of out here on the fringes, and the people in the city didn't have easy and quick access to that milk. And so it was observed that sometimes days old raw milk, which wasn't refrigerated either, was associated with increased risk of disease. And tuberculosis in particular is a very relevant disease that had a big impact on milk being pasteurised. So one of the people who made a very strong case for this, for pasteurising milk for the masses, was Professor G.S. Wilson. And as we all know, they recognised that milk was a very valuable nutrition source. But at the time, in the UK, this is in particular, bovine tuberculosis and brucellosis, which is another bacterial infection of cattle, were endemic, and it was impossible to get milk without, with a guarantee that it didn't contain these infections. And of course, even though it says bovine tuberculosis up there, these infections could be passed on to humans. And it's estimated that it's about 65,000, I think it adds up to, when you add up all the deaths between 1912 and 1937. That's tuberculosis alone. So it was a significant thing for these people. There were other pathogens of concern that occasionally turned up too in milk, the classic food poisoning ones that we might be familiar with, Salmonella, Listeria, Campylobacter. There were also diphtheria bacilli. So if the person milking the cow had diphtheria and had a bit of a cough into the milk pail, there goes the bacteria into the milk pail, and the next person that drinks it likely will become infected with that bacteria. So he made a very strong case, as did other people at the time. He did acknowledge that when the milk was pasteurised, it changed in taste, but did point out that it was only detectable by some people. And he also acknowledged that there was a decrease in minerals and vitamins and proteins in the milk after pasteurisation, but he felt, and quite rightly so I think at the time, that these negatives would be far outweighed by the decrease in illness and death that was currently being experienced. So pasteurisation became adopted by most developed countries as a way of making milk safe for the masses. So the type of pasteurisation that happens today is called HTST, or high temperature short time. So 15 to 30 seconds at about 72 degrees. And this was chosen because that temperature kills tuberculosis bacteria, which is relatively heat resistant. Now, pasteurisation doesn't actually kill all bacteria. But it does reduce the total bacterial load in whatever's being pasteurised to give it a 2-week shelf life at 4 degrees, so in the fridge. It does maintain the colour and some of the flavour of the milk better than at higher temperatures, but I understand, and I haven't done a lot of reading on this, that pasteurised milk is not so good for certain types of cheese production. That's another story altogether. It doesn't really concern us here tonight because we're here to talk about Moo View milk. And finally, UHT treatment, ultra high temperature, 95 degrees, kills everything. And when it's combined with a sterile filling of the container technology, you can keep it on the shelf. And we all know that UHT milk tastes nothing like fresh milk, don't we? It might be okay if you're camping for a week, but that's about all it's good for. So, do we still need to be pasteurising milk to prevent tuberculosis and brucellosis? Well, thanks to a fantastic eradication campaign begun in 1970, Australia is now free of bovine TB and brucellosis. Many other countries of the world are free of TB, and there are eradication programs underway in lots of other countries as well. So Australia was declared free officially of brucellosis in 1989 and tuberculosis in 1997. So my answer is no, you don't need to still pasteurise milk to prevent those things. Do we still need to pasteurise milk to prevent disease by other pathogens? So the diphtheria that I talked about earlier and the food poisoning bugs. I would say no, you don't need to. And there's a couple of factors in this. Having healthy cows, and Mark and Helen can talk more to how to achieve that than I can. But having healthy cows that are free of disease is one factor. Obtaining the milk in a hygienic manner, keeping it covered, clean and cold, all of those things will keep our milk safe and prevent any pathogens that might be in the environment or that you come in contact with to enter that milk. Milk does sour over time due to the normal flora in there because they use the lactose as their sugar source and produce acidic metabolites. And some people actually do this on purpose because they like the taste of it. I think kefir is one name, and I can't remember the names of some of the other drinks. But it's not dangerous for you. That's the point I'm trying to get across. Sour milk is just that, sour milk. It's not milk that's going to make you very sick. So, as we know, the Biosecurity SA visited Moo View Farm a couple of weeks ago, and they obtained several samples of the shareholders' milk. They tested it for any sort of bacteria that might be in there. None of the milk samples tested positive for any of the dangerous pathogens. One sample did test positive for E. coli at 10 times what's considered the acceptable level, but that sample came from a glass bottle which was provided by the shareholder, and when it was brought back to the dairy it has residual water in it, and so that tells us, since none of the other samples showed the same result, that E. coli actually came from the water, not from the milk. As a gesture of goodwill, Moo View has submitted several more samples for microbial testing, and we're still waiting on the results for that. They'll probably be in tomorrow or the next day. And the last thing I'd like to say about the standards for microbial limits for food is there's a clause in there that say that it doesn't actually apply to unpasteurised milk, which is not for retail sale, but we felt for our own peace of mind and for everybody else's peace of mind that we should do this probably on a regular basis to reassure ourselves and reassure anyone else who's worried about it that there is nothing to fear. So that's sort of the potential bad stuff. What about the good stuff? So what happens when you pasteurise milk to all the goodies that are in there? As I said before, human breast milk provides all infant nutrition for the first 6 months of their life. And in fact, the current World Health Organisation guidelines say that breastfeeding should be exclusive for the first 6 months and then to continue up to 2 years old and beyond. There's a growing body of scientific literature on the beneficial components of humans' milk and cows' milk and how these components are affected by pasteurisation. And there's so much out there that if I'd had a whole month, I think, to troll through all this literature just for the last 10 years, I wouldn't have got through it. There's a huge amount and it will continue to increase. So protein is the main component of milk. They're chains of amino acids that are then folded into secondary structures and even tertiary structures, folded some more, and sometimes even quaternary shapes if one protein subunit comes and joins another one to make a molecule. So this folding is very complex and it occurs inside the cells that make the protein. But the forces that hold that secondary structure in place is very weak and they're easily broken by heating it, even to 41 degrees. And note, that's not very high above human body temperature. So you don't have to go very far before the proteins start unfolding. And the critical thing is that when you cool them down again, they don't return to their original shape. And so they lose their biological activity. So I had a look at quite a lot of the literature on proteins in milk, and there's a number of things. If you'd like to know how they work, come and see me afterwards, but for the sake of time I won't go through all the mechanisms now. There's a protein called lactoperoxidase, which has been shown to be antibacterial. There's also one called lactoferrin, sometimes called lactotransferrin, which grabs hold of iron and takes it in and out of cells, but the fact that it grabs the iron prevents some bacteria from using it, so it's antibacterial in that way. It's also been shown to have antiviral activity, antifungal activity, and anti-tumour activity. Antibodies are secreted into milk, and they provide passive immunity to any sort of bacteria that might be infectious or virus or whatever that happens to be in the environment. So pasteurisation definitely knocks out the antibodies altogether and it reduces the activity of the other two, lactoferrin and lactoperoxidase. Casein, which is the main milk protein, is in fact a family of several different proteins, and the A1 and A2 milk. So the A1 and A2 milk, which you would have all seen and heard about, certain breeds of cows like Friesians produce mostly A1 milk, whereas other breeds like Guernseys, as well as sheep and goats, produce mainly milk that has the A2 type protein. So that's where that comes from. And some people find that the A1 milk in Australia and New Zealand gives them some unpleasant effects, and so they try the A2 milk, and that seems to make it better. So casein, the form it is in milk, it's sort of a spherical structure, so it forms what's called a micelle. So it's a circular structure with the water-loving part of the molecule on the outside and the water-hating part, if you like, on the inside, and the calcium ions actually are in the centre and they hold it together. And pasteurisation, it'll not surprise you to hear by now, that alters this structure and the immune reactivity of casein, which possibly leads to allergies. And one of the papers I read, altering that casein led to anaphylactic allergies, which is obviously life-threatening. So I'm sure you'll hear more about that from the research as it goes on. So what else is in milk? Sugar. Oligosaccharides, that's just a chemistry fancy word for sugar, but chemists are very particular. They like things to be named properly. So glucose we'd all be familiar with, single sugar, single subunit. Lactose, maltose and sucrose are disaccharides, so 2 subunits, and they are all in milk. They do a couple of different things. They're called prebiotics, and I learnt a new word this week, prebiotics. Prebiotics are defined as a non-digestible food ingredient that beneficially affects the host by selectively stimulating the growth of good bacteria in the colon and thus improving the host's health. So it's food for the good bugs, these disaccharides. They also act as decoy binding sites for any pathogens that might be around and prevent them from attaching to the cells of your gut, the mucosal cells. And I won't talk about the Holder method of pasteurisation now, but if you want to know about it, please come and see me afterwards at supper. So on the next slide, the milk fat, the good bit at the top that we all like. Cow's milk has so many different fatty acids in it that it would be an exhaustive list and exhausting if I were to talk about all of them. But just a few things about the fatty acids. There are these so-called medium-chain fatty acids, which can disrupt the walls of pathogens, and the sphingolipids and phospholipids, which also can prevent absorption of pathogenic bacteria and their toxins in the intestine. And by the way, these phospholipids and sphingolipids and cholesterol are all the normal part of our cell membrane. So we do actually all need to consume some fat, but in our affluent Western culture, let's face it, we absorb we eat way more than we need to, don't we? And pasteurisation and homogenisation, to no great surprise, do disrupt the structure of these components, and in doing so reduce their ability to have these antibacterial effects. So the last component I'm going to talk about are the white blood cells. So they're part of the immune system and they're the body's defence soldiers, if you like. Lots of white blood cells in milk. In particular, the ones I've got up there, the macrophages, neutrophils and natural killer cells, they kill bacteria by what's called phagocytosis, and I often describe this as Pac-Man. So, chomp, 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 along they come, they bind to the bacteria, they internalise it and then they kill it. And pasteurisation kills all of these white blood cells. So, just to summarise those things, I know it's a lot of information. Some of the components of raw milk that are protective for us, they encourage the growth of the normal flora in the gut, the good bacteria. They help destroy any pathogens that might be in the gut, or I've written in the milk there, but that's not really what I wanted to say, is destroy pathogens in our cells and in the milk if they happen to encounter the milk. These components prevent absorption of pathogens and toxins in the gut, and they ensure that we assimilate all of the nutrients that the milk has to offer. So, is drinking raw milk really risky behaviour? Well, 50 years ago, that may well have been the case, but today, in our enlightened age, there are many advancements in farming management, and again, Mark will be able to speak to this much more than I can, to ensure that cows are healthy and happy, to have an understanding of and to be able to detect for the zoonoses, which means infections that can move from one species to another, so cows to humans or another animal to cows to humans, etc. Understanding basic hygiene, how waterborne pathogens might get into milk, and have control measures in place to stop that from happening. Have effective cleaning systems in place. Refrigeration not only of the milk in the vat, but in whatever transport vehicle you're using to move it around. And also easier and inexpensive milk testing techniques should there be a suspected problem. So my answer again is no. In our day and age, drinking raw milk is not risky behaviour. So, to summarise what this means for Moo View milk, the milk comes from healthy, happy cows. The milk is clean, it's kept cool, and it's kept covered. I've been in the room where the vat is, and I was extremely impressed with the hygiene and the disinfection surrounding the bottling process. So I'm absolutely confident that it is clean. And in addition to that, Mark and Helen are people of integrity, and I trust them to maintain this procedure to keep their cows happy and healthy and keep our milk clean and cool and covered. And in addition, the microbial testing done so far has shown that there's been no problems. But if there is a problem, then we can find out and we can do something about it. So thank you for listening to all of that. And if anyone has any questions, I'll do my best to answer them. And if I don't know the answer straight away, I will find out and I'll get back to you. Thanks, Adam.
Thanks